Hello everyone. So here again I am with a new concept, and in this video we are going to talk about Euclid's division lemma. Euclid was the ancient Greek mathematician, and he has lot of contribution in mathematics, and he was the one who first recorded this in his book Elements. Then division, as we know, it has to do with the divisibility of integers. So let's talk first about divisibility of integers. So divisibility of integers states that if any positive integer a is divided by another positive integer b, there will be a unique integer q as quotient and will leave a unique integer r as remainder, and this remainder will be smaller than b. This is what reminds us of the long division which we have been doing, and mathematically can be written as dividend is equal to divisor into quotient plus remainder. Let's see a few examples. Like we have 17. This I can write down. If the divisor is 6, I'll get the quotient as 2 and remainder as 5. If I divide 5 by 12, so the quotient will be 0 and the remainder will be 5. And let's divide 20 by 4, so quotient will be 5 and remainder will be 0. If I divide 117 by 14, I'll get it 8 times and I'll have a remainder 5. So through these examples we can see that the quotient or the remainder can be 0 also. Okay, now restating this long division process which we have been doing as a is equal to bq plus r, where a remainder is always greater than or equal to 0 or it is less than b. So in first example we can see 5 is less than 6, and in second example we have 5 less than 12, third 0 less than 4, in fourth one we have 5 less than 14. So always r is less than b or equal to 0 or greater than 0. Now let's see, what do you mean by lemma? A lemma is a proven statement used for proving another statement. So now we know Euclid was a mathematician. Division is about the divisibility of integers, and lemma is a proven statement. So we are proving this statement, and that will be used for other mathematical statements. So now formally we can write down. So formal statement about Euclid's division lemma for any two given positive integers a and b, there exist unique integers q and r such that a is equal to bq plus r, where r is greater than or equal to 0 and less than b. So now let's do a few applications for this lemma. Show that every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1, where q is some integer. So in this case, let a be any positive integer, b be 2. Therefore, by Euclid's lemma, we can say a is equal to 2q plus r. Okay, and where r is greater than or equal to 0 and it is less than 2. Therefore, r is equal to 0 or 1, less than 2. So therefore, a is equal to 2q plus 0 is equal to 2q, or a is equal to 2q plus 1. So if a is in the form 2q, then it is an even integer because it has a factor as 2. And if a is in the form of 2q plus 1, so even number plus 1, then it is an odd integer. Hence shown. Let's take another example. Show that any positive odd integer is in the form 4q plus 1 or 4q plus 3, where q is some integer. Let a be a positive odd integer and b is equal to 4. Now applying Euclid's division lemma, we can write down a is equal to 4q plus r, where r is greater than or equal to 0 and less than 4. Therefore, r is equal to 0 or it is equal to 1 or 2 or 3. Therefore, a is equal to 4q plus 0 or a is equal to 4q plus 1 a is equal to 4q plus 2, or a is equal to 4q plus 3. And as a is odd integer, therefore a cannot be 4q or 4q plus 2, as both are divisible by 2. Any odd integer is of the form 4q plus 1 or 4q plus 3. Hence shown. So we have understood what is Euclid's division lemma, and we have applied it to. Now we will do more application for Euclid's division algorithm in the next video. So stay tuned and see you all.